3.4. Mixture problems, distance equals rate times time is one of the formulas we're going to need to know. Sometimes we need to know that the perimeter is twice the length plus twice the width. So there's some formulas. Area of a circle is pi r squared. Area of a rectangle is length times width. So we'll need to know some formulas for to be successful in this, and we're going to set up two systems of equations and solve systems of equations. And if you don't know how to do that successfully, watch a previous video either in 3.2 or 3.3. So here we go. Reading, not your favorite thing to do. I'm just going to kind of slide through these and just try to give you some hints. Whenever you see some money, I'm going to try to stick the money terms together and write a money equation. I would also, instead of using x's and y's, try to put the variables so that it kind of makes sense. For example, the circular stone sells for $26, so I would say 26C instead of 26X. So here comes my money line. So everything in this line better have to do with money. $26 for the circular stone, and means to add. The rectangular sells, so I'll use R for the rectangular. Sells for $34 for the rectangular, and then I'm going to put the total money, $11.38. So there's one system. The other system comes from, she made a total, and the total means you're going to add. No, that doesn't. In 1 month, she sold a total of 37. That's where it's coming from. So we don't know how many circular stones, we don't know how many rectangular stones, but we do know that there are 37 stones altogether. So this green equation has nothing to do with money. So again, to solve this, I would probably multiply the bottom equation through by a negative 26. And again, I'm not going to spend time showing you how to solve the systems of equations. I would recommend that you watch a previous video. Sometimes it's helpful to make a chart. So if you're a big chart fan, you can, but eventually you get down to these systems of equations, and here you go. You can pause the video and see how they have worked this out. The final answer is 22 and 15. But again, let's not write that as 22 comma 15 like an ordered pair, because I don't know if it's 15 comma 22 or 22 comma 15. So let's just leave them in terms of R and C, so I'll know which one is circular and which one is rectangular. Stating the final answer, 22 rectangular stones and 15 circular stones. Next example, I'm going to put some percentages together this time. So the key here is to look for percentages. So I've got a 30% acid solution. Let's see, to mix, company wishes to mix cleaner. There's 30% acid and 50% acid. So I was kind of looking for the name of these cleaners, and they don't really give a name, so I'll just say the first cleaning solution is X. The second cleaning solution, which is the 50%, I'll let be Y. And that's going to equal 35% of the total. And the total is 20 liters. So again, I don't know how many, or it's 30% of acid X, 50% of acid Y, and then when you mix these, it should be a 35% of the total liters. Well, that's one equation. The other equation has to do with just the total. I know that X plus Y, the total number of liters, is 20, would be a second solution. Again, to solve this system, I'd probably multiply the bottom equation. Well, you know, you could clear your decimals. If you multiply this through by 100, that will clean up this black line to give you 30x plus 50y is equal to, I didn't have to do 100, I guess I could have done 10. So I wonder what happens if I go back and do a 10. So now this is 3. I told you I wasn't going to spend time doing this. Now I got caught doing this. These are all like little time-saving things. So how about 3x, 5y, and then if I multiply this side by 10, I'll get 70. That simplifies things, because then I could multiply the bottom equation through by maybe -3. So a -3x minus 3y is equal to -60. Okay, you go ahead and solve the rest of this. Let's see how they wrote two systems. Here's their systems of equations. Let's see how they went ahead and solved it. I think they went ahead and they just kept working with the decimals in here. Eventually, we should get t equals 15 and f equals 5. So you can check those numbers again. The point of this lesson is how do you set up the systems, if you were interested in how to solve the systems, I would watch a previous video. So remember, we have some formulas to work with. Distance equals rate times time. Sometimes it's helpful to draw a little picture. Remember, you can always make a chart to organize your information. So that's sometimes really helpful, especially with distance formulas. So the next one says, Alex motorboat took a 4-hour trip. So I'm going to write down, distance equals rate times time, because it sounds like, we're dealing with a trip. And I'll go ahead and make a chart just to show you how that works. I've got downstream and I've got upstream, and I'm not sure what the distance is, but I do know that the distance down will equal the distance up. So I'm just going to leave it distance 1 and distance 2. They should be equal to each other. But the rates are different, because downstream he's got a current that's going to help push him. So it's 5 miles an hour faster going downstream. So whatever the rate of the boat is, I'll add 5, because it's not only the rate of the boat, it's also the rate of the current. So I'll add it. But on the way back, I've got the rate of the boat, but I'm going to subtract off 5 miles per hour for the current. And they give me some times here. The time that it takes to head downstream is only 4 hours, and the time to head back upstream is 6 hours. So again, I should know that if distance equals rate times time, then distance 1 is 4 times r plus 5. Distance 2 is 6 times r minus 5, and I know that d1 equals d2. So again, I'm not going to spend time showing you how to solve this. I think you can watch maybe the slides, but you know how to solve for r, and then after you solve for r, you can go back and solve for the distance if that's what they ask for. But they do ask for the speed, which is the rate of the boat. And so here's how the author here set it up. They also did a chart. I think we got those two equations. Once you get down to these two systems, go ahead and spend some time solving. I think this is where I left you out. So the rate turns out to be 25. Make sure you state your final answer, 25 miles per hour. Again, this is another mixture problem, so I'm going to put the percentages together. It looks like I've got 25% of, we can call it x, plus 10% of the y's. Maybe be better if I would have labeled those, because I'm not sure which one is the dried fruit and which one is the nuts. So I probably should have used D and N. But I do know that, that x plus y, I've got a total of 20 pounds. So 25% of the x's, which I think are the nuts, 10% of the dried, 10% of the nuts, so y is the nuts. I should probably label that over here. And x's must be the dried fruit. So it looks like I better read this before I start defining these things, because it looks like the question is asking how much deep thought, so that's got to be either an x or a y value, and how much oat dream. So it's 25% of the yellow, I'll let be deep thought, and this must be Oat Dream, because the nuts and the dried fruits are part of both. So the Oat Dream is the variable. That's a y. So there it is. Oat Dream is a y value, and that's the 10%. And then the Deep Thought is there's my x, is 25%, and this is my y, which is 10%. I think I'm okay. I got confused with what I was finding over here, but I think I have the correct system. Again, I probably, let's see. Well, I got to finish this out. 25% of the yellow plus 10% of the pink should equal 19% of the total pounds. And the total is right here. There's the 20 pounds. So again, you might want to multiply through by 100. So 25x plus 10y should equal 19 times 20. And then that just helps simplify, because now you can multiply the bottom equation through by maybe negative 10 is the smaller. You could have chosen negative 25, but I would choose the smaller, so we're trying to eliminate those y's. So again, I'm not going to spend time solving it. The goal of this video is to set up the systems and then make sure that you answer the question. It's not 12 pounds of nuts or 12 pounds of dried fruit. It's really 12 pounds of the X, which was the Deep Thought, and 8 pounds of the Y, which is the Oat Dream. So we better read carefully here. 18% of alcohol, so maybe I can write that as 0.18A plus 0.1 of the frost. Wait a minute. I better slow down here. I better read this. I'm going to mess up like I did on the last one here. I'm so sorry. How many liters of A should be mixed with 7? So how many liters of A should be mixed with 7.5 to get a total? I think my unknown isn't the frost. I think my unknown is the total. So how many liters of A should be mixed with 7.5? So they're giving me the number of liters of the frost, but I don't know what the total is. But I do know that the mixture is 10% of the frost, which I'm using. So they're telling me that I'm using, I know the amount of the frost will always be 7.5. They're telling me I should. So that's a variable I don't need to use F for, because they're telling me that I'm using 7.5 liters of the frost. So I know the percentage of the frost, 10%. I know the quantity of the frost, 7.5. I just don't know the total, but I do know that the total is supposed to be 15% of the total. So I'm not going to use A and F for my variables. This time I'm using A and T standing for the total. So on this particular, that was hard. On this particular problem, you need to maybe sub in for T, and you could do a substitution and back substitute for A and B. Yep, good. Looks like the author agrees here. If you work this out, either substitution or linear combinations, it doesn't matter which method, you should get 12.5 and 20. And then you might want to state these answers so it makes sense. A couple more here. A car, whenever they talk about speed, I think I'm going to use distance equals rate times time. Chart again. So the distance looks like is going to be the same. So Max and Olivia are both taking off in the same place. They're still going to, I think they're going to drive the same amount of distance, because we want to know if Olivia takes off an hour later. So if Max goes for time t, Olivia is going to be driving for 1 hour less. So I'll put t minus 1 there. But Max's rate is 80 miles an hour, or kilometers per hour, and Olivia is going much faster at 96 and will eventually catch up. And then again, D1 will equal D2. So D1 is distance equals rate times time, ADT. D2 is 90 times t minus 1. And I would set those equal to each other. So because distance 1 equals distance 2, that when Olivia catches up with Max, they will have traveled the same distance. So 90t minus 90. You can solve for t. I think this is a 96 right there. So this should have been 96. 96. So subtracting off 96, I get negative 16t equals negative 96, and t is equal to 6, but be careful and answer the question. The question wasn't how long, the question was how far. So I'm going to have to take that t equals 6 and maybe go 80 times to get the distance. So 80 times 6 will be my 480 kilometers. So we always want to answer the question. Yeah, it looks like the author has the same answer. Last example. Oh, looks like another distance equals rate times time. This time, let's see what's given. We've got a slower plane that's traveling at a rate of 190, and we have a faster plane that's going at a rate of 200. Oftentimes, I was trying to read up here, because oftentimes when I deal with rivers and planes flying, we're dealing with like airspeed or the current of the river. So I think this must not have any air, wind speed that we have to worry about. So we don't know the distance of the slower, and we don't know the distance of the faster, but we do know that they're 780 kilometers apart. So if the slow plane did 80, then this is 700. So all I have to do is 780 minus D1. So I don't know distance 2, but I do know that distance 1 and distance 2 gives a total distance of 780. That was tricky. And I think that the times are going to be the same. And how many hours will they meet? Well, when they meet, they will be flying for the same time. So that was first equation, distance equals rate times time. And the distance here will equal 200t. For the equation A, I'd probably divide through by 190. Let's call this time 1 and call this time 2, because I know that time 1 should equal time 2. So time 1 would be d divided by 190. Time 2 is 780 minus d over 200. And then I would set those two times equal to each other. And cross multiply. So this diagonal, 190 times 780 minus d is equal to 200d. And I think you're home free. I think you can solve for d, but go back. They don't ask for d. They say how many hours. So after you solve for d, you'd have to plug it back in and solve for time. But that's easy. You could just go to this equation right here, and d divided by 190 should give your solution. So again, I'm not going to spend the time just show you how to solve the systems, but you should end up with 2 hours. And when you solve for d, I think d turns out to be like 380, because looking at this, the 380 should be the 190 times the 2. Distance equals the 190 times the time. So I think that's going to be a 380 for the distance, but they didn't ask for distance. They asked for time. So, but in order to solve for time, you're going to have to find distance first. So again, solve for distance over here, which it must be 380, and then plug that back in take 380, divide by 190, and solve for time, which will end up to be 2. I hope this video was helpful. Email me with your questions.